So welcome back children. Today let us discuss something regarding the mirror formula, also called as Gauss formula, mirror equation or Gauss formula. So this indicates the relation between the object distance, image distance as well as the radius of curvature or focal length. So let us try to derive the relation between them. For this, let us consider a mirror. Let it be some concave mirror. Consider a concave mirror. Concave mirror is basically a mirror that is coated outside, so that the reflecting surface will be from the inner portion. This will be your principal axis. Our main concept is all regarding the Gauss formula or mirror equation. Consider a concave mirror. So, let P be the pole of this concave mirror and this line be the principal axis. Any line that is sent parallel to the principal axis after reflection from the convex mirror will reflect back and meets the principal axis at a point F. Meets the principal axis at a point F. Let us suppose that an object is placed at some far away distance. The name of the object be named as some AB. Let AB be the object. The parallel beam of light rays passing from the object strikes the mirror at some point, say B, at some point, say P dash, and after reflection meets the principal axis at point F. Any light ray that is sent through the center of curvature of the mirror, after passing through the center of curvature, the light ray after passing through the center of curvature, again reflected back through the same direction. The point at which the parallel beam of light rays after reflection and the light ray that is passing through the center of curvature meets, at that particular point, the image of the object is being observed. The image of the object is being observed. Let us name this image as A dash, B dash. Let A be the object, AB be the object at some distance U, and A dash, B dash be the image of the given object. Okay. So now let us try to get the relation between these three, and let us also suppose that the distance between the object and the pole of the mirror be U, the distance between the center of curvature and pole of the mirror be R, and the distance between the focal length, focus and the principal pole of the mirror be indicated by F. The distance between object and the pole be U, that is object distance, and the distance between center of curvature and pole called as radius of curvature indicated with the letter, and the distance between the focus and the distance between the image and the pole of the mirror be indicated with the letter V. This portion let us indicate with the letter V. And the distance between the focus, principal focus and pole of the mirror is called as focal length indicated with the letter F. indicated with the letter F. This complete portion is called F. So, 4 conditions I have given you. This is F. From here to here it is F. From here to here it is V. From here to here it is R. And from here to here it is U. So, if you observe the picture carefully, you can observe 2 similar triangles. Let us focus on those 2 similar triangles. One triangle must be A, B and CB. Yes. This is one triangle, bigger triangle, and here is one more triangle, smaller triangle. If you observe the 2 triangles carefully, they both are similar triangles. The reason for similar triangles are these 2 are alternate interior vertically opposite angles. Okay, and this is the common line for both the cases. And this is a right angle at B and B dash. From ASA property, we can say that both the triangles are similar. So, for the similar triangles, since triangle ABC is similar to triangle A dash B dash C, we can conclude that this portion AB upon the other portion, that is A dash B dash, must be equals to AB upon A dash B dash must be equals to this length, that is CB, from here to here CB, and again from here to here, that is CB dash. Let this be equation 1. Let this be equation 1. Similarly, if you observe one more part, that is triangle. So, let us consider one more portion, children. If I produce this from A to P, pole of the mirror, it forms a triangle. And also, if A dash is produced to B, here also one more triangle is being formed. Again, we observe that the triangle ABP and A dash B dash P are also similar. So, from figure, we can also conclude that triangle ABP is similar to triangle A dash B dash P. The reason for this is, again, angle B and B dash are maintained at 90 degrees. Okay. This is the common line, and these 2 are parallel lines. Even then, this angle is equals to the other angle, this reflected ray. Okay. Whenever a ray of light strikes at the pole of the mirror, the angle between the incident ray and the principal axis is always equals to the angle between the reflected ray and the principal axis. So, these 2 angles are equal. One angle, these 2 are maintained at 90 degrees, second angle, and this is a common principal axis. From ASA property, we can conclude that triangle ABP is similar to triangle A dash B dash P. So, from these 2 triangles, we can conclude that AB upon A dash B dash, AB from bigger triangle AB, smaller triangle A dash B dash must be equals to the other part is from here on the principal axis. This total length is taken as PB and this total length is taken as PB dash. Let this be equation 2. So, equation 1, we have AB by A dash B dash equals to CB by CB dash, And in equation 2, AB by A dash B dash equals to PB by PB dash. Comparing equation 1 and 2, we can conclude that as LHS is equal, RHS can be equated. That is CB by CB dash is equals to PB by PB dash. So this is the conclusion. If you observe the picture carefully, CB, this portion CB is this portion can be written as the total length minus this portion. The total length minus PC will give you the remaining portion CB. That means CB, this CB can be written as the total length, that is PB minus this portion, that is PC. PB minus PC will give you the value of CB. CB is equals to PB minus PC. Now moving to the CB dash, this portion. In order to get this CB dash, this can also be written as the total portion, okay, CB dash can be written as this total value PC minus this removed portion PB dash. PC can be written as, CB dash can be written as PC minus PB dash. Okay. So, CB dash can be written as the total length, that is PC minus this portion, that is PB dash is equals to PB upon PB dash. I hope the equation is clear, children. Once the equation is clear, let us substitute their values carefully. So what we can conclude is, substituting all the values. The value of PB, where is PB? From here to here. The total length from PB is written as U minus PC. PC means from here to here. This portion itself is called as radius of curvature R upon PC. PC is again radius of curvature R minus PB dash. PB dash is this portion. Image to pole indicated with the letter V equals to PB. PB means from here to here, the total length is the length of the object, distance of the object U. Again, PB dash means this is the distance. This distance is the distance of the image given as V. So, U minus R by R minus V is equals to U by V. Cross multiplying UV minus RV equals to UR minus UV. So, bringing this minus UV the other side, you have UV plus UV is equals to, already you are having UR here, minus RV bringing to the other side will become plus RV. So, you have 2UV is equals to UR plus RV. This is the equation we have proved for. So, now dividing the above equation. Let us completely divide the above equation with UV. Dividing the whole equation with UV, we have 2UV upon UV is equals to UR by UV plus RV by UV. So, completely the whole equation once divided with UV, what you are getting is UV cancelled, U get cancelled and V gets cancelled. So, you are left with 2 is equals to R by V plus R by U. So, 2 is equals to R once taken common, you are left with 1 by V plus 1 by U. So, bringing the R to the other side, we have 2 by R is equals to 1 by U, rearranging the terms, 1 by U plus 1 by V. So, the relation between the radius of curvature U object distance and V image distance is given as 2 by R is equals to 1 by U plus 1 by V. But children, we know that the relation between R and F is, since R is equals to 2F, R is equals to 2F, let us replace the same. 2 by R is now replaced with 2F is equals to 1 by U plus 1 by V. This 2 and 2 gets cancelled. We have 1 by F is equals to 1 by U plus 1 by V. This formula itself is called as your Gauss formula. The relation between the focal length, object distance and image distance is given as 1 by F is equals to 1 by U plus 1 by V. So, this formula itself is called as a mirror equation or Gauss formula. Okay, children. And one more thing, remember children, the direction of the distances. Okay, distances, if it is in the direction of the light ray, it is taken as positive, and the direction opposite to the light ray is always taken as negative. So, regarding this, we will discuss in detail later. First of all, let us move to the next concept, is all about your magnification. Okay. So, what is mirror equation, children? So, mirror equation is nothing the equation relating to the object distance, the equation relating to the object distance, image distance and focal length. This relation, the relation between that indicates the relation between object distance, image distance and focal length is called as your mirror equation. Now moving to the next one, all about your magnification. So, or generally called as your linear magnification. Next topic is all about your linear magnification or simply magnification. Generally indicated with the letter M. So, how it is defined means, it is defined as the ratio of the size of the image to the size of the object. Whenever a light ray is reflected from the mirror, linear magnification indicated with the letter M is defined as the ratio of size of the image to the size of the object when reflected from a mirror. Whenever a light ray is reflected from a mirror, the ratio of the image to the ratio of size of the image to the size of the object is called as your magnification. Simple forms. M means a magnification, I indicates size of image, and O indicates size of object. That's it. The same can be also indicated in terms of height. Size of image. If size of image is indicated with the letter height H2, if size of the image indicated with the height H2 and size of the object indicated with the letter H1, then magnification can also be written as H2 by H1. So, in this case, this is the size of the image, A dash, B dash is the size of the image and AB is indicated as the size of the object. This total height to the height of the image to the height of the object itself is called as your magnification. Got it, children? Well, you also have to apply the sign convention. So, when is magnification positive and when is magnification negative? In case of real image, the image is formed inverted. Real image is always inverted. Real image is generally formed by using a concave mirror. So, in this, when it is inverted, the image will be negative even though object will be positive. So, in this particular case, the magnification will be positive. Similarly, if you go with a convex mirror, in the case of a convex mirror, if you observe it carefully, then virtual image is formed. In the case of convex mirror, virtual image is formed. So, in the virtual image, both image is negative, whereas